Okay, so in this video I'm going to try and teach you how to solve equations that have radicals in them. So when you see an equation, it means it has an equal sign in it. So instead of it being just c plus 8 equals 13, that would be easy. You take the 8 to the other side and subtract, and you'd say, c equals 5. You can get that answer. But what if it's a square root in there? How is it that you're going to solve a question like that? If there's radicals in the equation, how do we solve them? So there's some methods that you will do to try and solve that. The first step you will do when you see an equation that has a radical in it, the first step that you will do is you will isolate the radical. You will get the radical by itself, so anything that's with it has to go away. And then, once you've isolated the radical, you will solve by squaring both sides. Okay, so step 1, isolate the radical. Step 2, square both sides. Step 3, solve for x. So let's put that together and see what happens with this question. So if you have 5 plus the square root of 2x minus 1 equals 12. Your first goal is to take this radical and get it by itself. There's a 5 that's with it. So I'm going to take 5 to the other side. Thus, I will be isolating the radical. So if I took the 5 to the other side, then the square root of 2x minus 1 is going to be left on the left. And I would take the 5 to the other side, and it will become a subtract 5. So I will have square root of 2x minus 1 equals 7. Now if you've got a radical, the next step to do is to take both sides and square them. Now this step of squaring both sides can sometimes introduce answers that may not be correct. So when we do this, you should always check your answer to make sure it works at the end, because if it doesn't, it'll have a fancy name called an extraneous root. But we'll get into that after. So squaring both sides can be a problem. We'll square both sides and see what happens. Remembering we'll have to check the answer afterwards. Now, when you square root a square, they cancel each other out just like a magician. No, they're gone, and you leave 2x minus 1 behind. And on the right-hand side, 7 squared is 49. So now you've made the equation easier. There's no more radical there. So now it's easier to solve. Take the 1 to the other side. 2x now equals 49 plus 1. 2x equals 50. And therefore divide both sides by 2. X equals 25. But you should go back to the original and check your answer. You need to do this. If you don't check your answer afterwards, I'm going to take off marks. So you have to check your answer. So you go back to your original equation. 5 square root of 2x minus 1 equals 12. And show me that it equals that. You literally have to plug it in and show me. So 5 square root 2 times 25, plug it back in for x. 2 times 25, subtract 1, all under the radical. Does that equal 12? We can do this without a calculator. 50 minus 1. So 5 plus 50 minus 1 is 49. Square root of 49. Straight above where this is in the smartboard, you see root 49 equals 7. 5 plus 7 equals 12. Hey, look at that, it works. 12 equals 12. Profound mathematical statement, but therefore you've checked. You know x equals 25 is indeed an answer to the question. So our steps were to get the radical alone, square both sides, solve for x. Let's look at a slightly harder question. Fractions, don't freak out. So you have minus 8 plus square root of 3y divided by 5 equals negative 2. This is the radical term. You want it alone. So you take the thing that's with it to the other side, and then it's isolated. So we will leave 3y divided by 5 here. Take the negative 8 to the other side, and it becomes a plus 8. So we now have 3y divided by 5 equals 6. You will now square both sides. The square and the square root cancels. Leaves 3y over 5 equals 36. You can now try and get y by itself. 5 comes up and multiplies. So 3y equals 36 times 5. So 3y equals 180. Divide by 3, and you get 60. And you have to then go check that answer. Before you're certain of the 60, you've got to plug it back into there and show that it works. Is negative 8 plus square root of 3 times 60 over 5 actually equal to negative 2? So the square root of 180 over 5. 180 over 5 is 36. Square root of 36 is 6. And negative 8 plus 6 is negative 2. So they equal each other. Therefore, you're confident that 60 is an answer to the question. Now, sometimes when you check, the answer will not work. When that happens, we call that an extraneous root. It's a solution to an equation that seems to be right, but when we check it by substituting it in, it actually turns out to not be the case. And the reason is because sometimes when you square this, you get extra answers. Because sometimes when you take negative 3 and you square it, you also get 9. When you're doing square roots, there's plus or minuses in. 3 squared is also 9. Sometimes a negative answer or a positive answer looks like it's going to lead you to the right thing, but it's not quite true. Okay? Negative 3 does not equal 3, but if you square both sides, 9 does equal 9. So the squaring both sides is a problem. You've got to sometimes check that you didn't introduce an error. Okay? That's the whole reason behind extraneous roots and checking it. It's not just me being an anal math teacher. It means you've got to actually check and see if something went wrong. Okay, so now in this question, you see a regular variable, n, you see a radical, and a 7. But the steps are still the same. Isolate the radical. Now this radical sign is negative, so I'm actually going to take it to the other side and make it positive, and I'm going to take the negative 7 this way. and make it positive. So I'm going to get n plus 7 equals the positive square root of 5 minus n. Negative 7 goes to the left, negative root goes to the right, both of them become positives. Then I will square both sides, recognizing it might cause us a problem. Squaring both sides, for the love of all that's holy, do not call this n squared plus 49. You cannot just put the square on both terms when there's a plus in there. No, 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 no. N plus 7 squared means n plus 7 onto n plus 7, which means you gotta FOIL that. N squared plus 7n plus another 7n plus 49. N plus 7 squared is n squared plus 14n plus 49. You cannot just distribute that square and call it n squared plus 49. Wrong, wrong, wrong. Squaring the square root, good news, it disappears and leaves 5 minus n. Still leaves 5 minus n. Still leaves 5 minus n. Now I'm seeing something gross, like quadratics and stuff. So I'll take everything to the other side and make this equal 0. N squared plus 14n plus 1n plus 49 minus 5 equals 0. Took the 5 to the other side, made it negative. Took the n to the other side, made it positive. So I have n squared plus 15n plus 44 equals 0. Good news, in grade 10, we taught you how to factor this equation. You play the game of what multiplies to give 44 and what adds to give 15. Factors of 44, like 4 times 11 makes 44, and 4 plus 11 makes 15. So the magic numbers are 4 and 11. You then break that up into n plus 4 and n plus 11 equals 0. That lets you get two solutions. You set the first bracket equal to 0 and the second bracket equal to 0 and solve each. So n equals negative 4 and n equals negative 11. Both of those answers could be correct. You've got to go back to that original equation, n minus root 5 minus n equals, I already forgot it, negative 7. You have to plug both the negative 4 in and then the negative 11 in and see if they both work. I'll plug in negative 4 first. Is negative 4 subtract 5 minus negative 4 actually equal to negative 7? Is negative 4 subtract 5 plus 4 equal to negative 7? Negative 4 subtract root 9. Oops, negative 7. Negative 4 minus 3, I keep writing the 3 down. Negative 4 minus 3 is actually equal to negative 7. So negative 4 works. We'll try negative 11 and check that answer. Just a bit more. So if you plugged in negative 11 instead, you'd have negative 11 minus square root of 5 minus negative 11. Does that equal negative 7? Negative 11, subtract root 16 equals negative 7. Negative 11 minus 4 equals negative 7. Negative 15, nope, does not equal negative 7. The negative 11 plus 4, if the root was positive, it would have worked. And that's that whole square root plus or minus introducing an extra answer when you square it. This is an extraneous root and does not count. So you've got to plug it in, show me, and label it as a root that does not work for me to reward you all of the points for the question. So isolate, to sum up, isolate the radical, square both sides, solve, check is how the steps you follow to solve these problems. All right, so we'll give you some questions to try and see if you can have some success. Good luck.